cross flow device. So cross flow device can be used for vertical or horizontal vessels. So cross flow is fluid, water will be flowing one direction, but its separation will be another direction. Okay. So water will be flowing horizontally, but your particle will be moving vertically. So plates can have larger angle for sedimentation issue. So like I told, instead of 45 degree you are giving 60 degree. So in this case also you are increasing angle, but sand settlement and pressure thing if you have separator, so this separator will be better for sand handling and for pressure vessels. Like normally you will be having atmospheric vessel where you are not applying any pressure, but you have applied already pressure. So in that case, this cross flow device is better vessel. It will be cheaper and efficient. Okay. So preferred for pressure vessel and more sedimentation if you have. So cross flow device can be constructed either horizontal or vertical pressure vessel. Horizontal vessel require less internal baffling as the ends of nearly each plate contact the oil directly to the oil water interface. Okay. So however, the pack is long and narrow and therefore it requires elaborate spreader and collector device to force water travel across the plate pack and plug. There is a possibility of shearing the inlet oil. So if shearing is happening, the separation will be difficult. Shearing happening means oil particle is getting sheared, so particle size will be smaller. So DM smaller means difficulty. Right? Larger DM is better. So in some cases particle shearing possible, so that will be creating much difficulty separating oil particle from water. Whenever you are using separating system like CPI or parallel plate interceptor, so in that case what happens? There is no moving particle. So whenever you are designing mechanical element, if you have lots of moving element, that means your life will be difficult. The moving element or relative motion will be there. It's two machine element relative motion. So the life will be lower because there will be friction. There may be some clogging or blocking. Machine element you are trying to move but it's not moving because of friction. So that will create much problem. So in this system, like parallel plate or corrugated plate, whatever system you are using, there is no moving element. Just one system, static system, and you are separating. It's better. But in many cases, people will be using centrifuge also, just to reduce oil particle amount. Okay. Similarly, hydrocyclone also good thing because there is no moving element. So whenever limited amount of moving element is there, system is better. Larger moving element means you have to give electricity, then you have to maintain things, greasing, bearing. So many things are there. Okay, so you have to try to reduce moving element, number of moving. Number of moving element increasing means your system reliability will be reduced because every system will have their own reliability. Okay, so 1, 2, 3, 4 multiple systems are there, so total reliability is going down. Okay, so there is no moving element, so life is not there. But only thing is that cleaning will be required sometimes, time to time. The sand deposition and debris deposition will be there. In that case, cleaning may be required. Now, coalescer sizing equation. HWL equals 4.8 QWH mu divided by cos theta dm square del S. So we'll try to see what is this equation. So dm is the oil droplet diameter, already you know, micron meter or micron. Del H is specific gravity difference. H you know water level height. Okay, W width of the separator system. L is the length of plate section. Length GTH of plate section. Parallel to the axis of water. Okay, W is width. Del SG already you know, specific gravity difference. Theta is there. So this is angle. Okay, angle of the plate with horizontal. Mu viscosity Cp you already know. So now we'll see how to formulate this one. So first you have to draw this parallel plate. This is h, this distance, this angle is theta. We have seen already parallel plate, right? And let's say I have one particle here, oil particle. Okay, so oil particle is going up, vertically up. Okay, it is moving vertically up. So how much distance is traveling? This whole is A, B. I'm giving this name. This is the perpendicular. So actually BC equals H. You can see BC equals H, but AB and H is not equal, right? AB is hypotenuse. Okay. Perpendicular distance between plate is H, but oil is flowing just a little bit with angle, so it is traveling a little bit more, right? Now how to derive it? So TW equals TO, we know already the basic formula, right? Oil time and water time equal, retention time. So TW equals effective length divided by VW. So effective length here in plate interceptor, we are using 70%. 70% of the actual length will be used. Okay, because it's entry and exit. Some portion will not be used actually. So they are using 70% of the length will be used. So 70% of the length is used. Assume. Okay. So V VW equals Q by A, and Q already we know 6.49 10 power minus 5 QW, because this is just unit conversion. So QWBPT and Q in feet, cubic feet per second. So and A equals 0.9 H. There is plate material itself takes 10% space. Okay, plate material, one layer, two layer, three layer. Okay, so total many layers you are using. So plate material also will be taking some space. Okay, so there is a plate material takes 10%. Takes 10% space. So finally TW becoming 0.7 L into 0.9 HW, then QW 6.49 10 power minus 5 QW, H in inch, H inch. So what is AB distance? This is theta, so this will be theta, right? Angle ABC, angle ABC is theta, right? So how to calculate H? AB sin theta, right? This is base, this is hypotenuse. So H equals AB. Okay, correct. AB cos theta. So H equals AB cos theta. Now what is AB? AB actually the particle velocity and time. Okay, so particle velocity and time is TO cos theta, while velocity into V. Okay, so now I can get TO equals H divided by 12 cos theta into V. Now TO equals TW. This will be giving HWL equals 4.8 cos theta LSG into dm square. This is the final form of equation. So now another equation is the HW equals 40.10 power minus 4 QWHSG del SG W SG divided by mu. So this formula will be right. Actually, we are saying that from Reynolds number you have to derive this one. So R is hydraulic radius. Okay, so whenever say hydraulic radius, you can remember for rectangular area, it will be A by P. A means area, weighted area by perimeter. Okay, weighted perimeter, weighted area. How? Actually, you have one channel. Okay, so this is, let's say, A, or let's say P. This is Q. I should mix up P. I like some different name. Alpha, beta. That should not get mixed up. So area is alpha into beta, and perimeter is alpha plus beta plus alpha. Alpha plus beta plus alpha. Okay, so this is area, weighted area by perimeter. Now, hydraulic radius formula is this: HW by 12, 1 by 2WH, where okay, yeah. So this is the formula, and they are approximating if H is half of W, then it will be like this: H by 12, just approx. H by 12, H by 12. Just approximation they have done. And Reynolds number value they are taking VW D rho W mu dash G and mu in CP. So mu dash they are converting as like this: 2.088 to 10 power minus 5 mu. And unit is different actually. Mu dash will be per second. Feet square. T is 4R. So this gives VW equals 5.61 QW 3600 into 0.9 HW. Rho value we have to change. Rho W equals 62.4 SG. So finally HW coming 14 into 10 power minus 4 QWH SG W and divided by mu. Okay. So to account for surge from auto valve, use safety factor of 2. So they have to use safety factor 2. Using safety factor 2, this formula finally comes. So final version if you remember, or in between somewhere, some step I can give some calculation, some formula, I can give some confusion somewhere, or maybe final formula if you are not remembering, maybe I can give, change some parameter. For example, instead of 14 I can say 27. And I give option like, I can give option like 1, 14, 27, 100, constant term. So what is the correct? So you can remember the last one, or maybe you can derive and you can come back. Precipitator. Precipitator schematic. So it is like on separated system. You have multimedia filter. Okay. So this is a filter they are using. It's called Excelsior. Excelsior or other coalescing medium. Okay, so here inlet is there and inlet will be going through this with and it will go through this to exit. This, then you are creating water here, water. Okay. And while you are creating here, while there you are creating this oil. And while there is there, then you have to create a wear also. While there, and from there oil you take. Water there, this is water there. The right water here. So here we are not using as mist extractor, which is normal atmospheric vessel. But if you have high pressure system, then you have to use mist extractor, gas line also. But we are assuming that gas is very negligible. So we may have gas extractor, or maybe we putting also that one, so that if any extra gas coming out, that we can take it. But normally we will not have gas much. So oil. So it will be possible to this Excelsior. So to create extra resistance also. This is called sometimes they call SP pack. There's some companies give the term called SP pack. Okay. So instead of horizontal vertical thing, they are getting Excelsior so that you are separating, but it will enhance capability. The company put the name SP pack. So efficiency of SP pack. So efficiency they have one formula. EG equals 1 minus 1 minus power n. ET is total. It is over the efficiency overall efficiency. This is each cell. So you create multiple cells. So each cell is having efficiency. So overall efficiency formula will be like this. And n is the number of cells, number of stages. Okay. So this simple formula later we'll use and see how to use it. Okay. This is flotation. Okay, so there are two types of flotation. One will be dissolved gas unit. Flotation means you are using gas and you are assisting separating oil particle from water. Okay, so that term is they are using flotation unit. Okay. So flotation units are the only commonly used water treating equipment that do not rely solely on gravity separation. Okay, they are not relying solely on gravity separation. They are attaching air bubble and trying to push the oil particle up, so that the oil particle will create one layer over water layer and you can separate. Okay. Flotation units employ a process in which fine gas bubbles are generated and dispersed in water where they attach themselves to the oil droplet or solid particulate. Okay. So when oil droplet is here and let's say some gas bubble is attached here. So total average density went up because the gas is there. So it will be trying to moving up. Total volume increased, okay, because of the air included. So it will be moving up quick. So flotation aids such as coagulant, polyelectrolytes, emulsifiers are added to improve performance. Two distinct type flotation units will be one is dissolved gas unit, one will be dispersed gas unit. Okay, so we'll see what are the different techniques. So one is dissolved gas unit. We have one chamber like this, inlet. Okay, and this is oil, and small amount of gas is there. It will and water will be larger amount, or will be very small amount. Okay, and this will have one contact gas giving recycling pump. So whatever water you are getting, you are recycling, but you are giving gas. Those gas will give lots of mixture when mixing up with water. So it will create a flotation. It will make oil particle easier to move up. Okay. So basically it is used different ways where instead of upstream things, but many cases upstream also people use. Dispersed gas unit more successful. Limited offshore use is there because of larger unit. So this dissolved gas unit, and another is dispersed gas unit. Dispersed gas unit, uh, dissolved gas unit, you are giving gas inlet pipe and you are dispersing, mixing and dissolving. And dispersed unit, in dispersed unit, what is happening? You have one basic system here, and you give gas here, not gas, water. Okay, water pipe will be going through this, and you create one nozzle suction. Using nozzle, you mix up gas and water. And when you are getting nozzle, very high velocity fluid will be going to the water. At that time, gas will be sucked. Gas and water getting sucked and getting mixed up. When it is mixing, oil and water, gas and oil particle will try to float. Okay, because of the mix up and it gets separate. So you can create separate cells also. Many cells and many nozzles you can create. And over the water surface, the froth will be created. So that froth you take out oil and water from bottom you take. The same water may be inject. Okay, so this recirculation will happen. Okay, so this some distinct difference I got from document website. So like air is mixed with liquid, not dissolved in induced or dispersed air filtration system. For dissolved gas system, air is dissolved in liquid, air saturation is required. Okay, so larger amount of air will be there. And air bubble size, a larger will be there in this case. This dissolved case, air bubble size will be smaller. Okay. Sometimes in this case, chemical can be added. Dissolved gas also chemical will be added. Uh, Turbulence below or at surface should be minimal in well designed and operated system or dissolved gas system. But in this system, energy and shear turbulence are generally greater. So you can try to remember these differences. Okay, thank you very much. So we'll start next lecture, next topic.